he's okay with that.
Sure.
Okay.
Yeah. Go on. As soon as you want us to do something, we'll do it.
Yeah, I mean, I don't want to record off-topic conversations. So, all right, I think the recorder is on. So the first item on the agenda was to review our action items. We do have an action item list. There was an action item we took last time to gather more input on the feasibility of multiple proposals that we have on the table. It's owned by the whole design team. If anybody has an update on this, I'm willing to capture that. I guess silence means no one has an update.
So we have had discussions internally, and I think we're okay, but you know, there's still not enough details. So we will provide feedback as we go along. We also have a quote from the draft.
When you say Kiriti, we you know, I think you're
Juniper, yeah.
Juniper, yeah. Okay. So,
but I was just starting to say that we have a Broadcom co-author on the draft, and so we are also talking with them in terms of feasibility.
Oh, good.
Yeah. We do need to run the latest version by them and make sure that we're not going, you know, off the beaten path there. But I'll do that. Probably not before the Ietf, but maybe. So we can talk about it then.
okay.
The presentation I gave 2 weeks ago is also the result of an internal discussion with our team who has designed network processors before.
Is that Huawei, right?
Yes.
So, and the discussions reveal positive. Is it positive? Feasibility is okay. Is that what you were trying to say?
Yeah, I gave several recommendation on how the headers should be designed. So what helps, what doesn't help, just to make things more complex.
Okay, and what do you want me to capture in here? Like, do you have concerns with the proposals on the table?
Yes, basically the practice to first use a catalog like art structure to to tell what follows at some previous location, and use pointer to jump around between the different headers. Those practices, not helpful and also makes the things more complex.
I remember when you were presenting this discussion, there was no consensus on, although you might be one implementation, you were talking about one implementation, but it was not universal.
That's all current implementation. I cover both ASIC and network processor, software business processor. Those apply, but it's of course in the future. I don't cover any future design, but just for the current ASIC and network processor perspective.
Yeah, I'm skeptical to capture that as all processes because there was a discussion at that time, and
yeah, I just represented one vendor, right? So you can.
Yeah, okay, that I can take
from others.
So what do you want me to capture? Like, do you have a specific concern? Like what you said, pointers.
Pointers and the catalogs. You should avoid that. Avoid those. That doesn't help.
Well, one architecture can't do it, I think is what you're saying.
What? Excuse me.
You're just saying that one architecture can't do it. Is that right?
Not one architecture. I said, in the current ASIC and the network processor, in terms of the parser, that doesn't help. Those mechanisms is actually doesn't help and also makes things more complex.
So, Tarek, I think it's better to use how you use words. The architecture is not helped by pointers and catalogs, as opposed to cannot
Which
do.
architecture? I mean, that's the
Huawei
concern.
architecture.
That's because they were never designed to do it, of
Not
course.
Huawei is also based on my understanding of the current product in market.
But that's because they were not.
Why are you writing Huawei?
Because YU speaks for Huawei, right? That's
No, he doesn't.
I don't speak for Huawei. That's some basic understanding for the product around the market, because the team has experience on the design of those kind of chips.
I did ask a little while ago. You represent Huawei, and okay, maybe I got the right. You misunderstood.
He needs to be a bit careful. If he has detailed technical discussions with Huawei, he risks getting arrested. So, I think you need to be really careful what you write.
So I think it would be more appropriate if you. So first of all, I thought we're all individual contributors. I don't think you're actually following that line. Juniper, Huawei, or so. But I think
I think it's important to get feedback on what different architectures can do. And I have conversations with our ASIC guys, and I'm okay to speak for them. You can use the data that I provide in any way that you want. I asked the same thing of the Broadcom guys. And again, you can do what you want with it. But I think, if you're going to make a meaningful changes to the architecture of MPLS, we should understand what chips can and cannot do, and how they would like to see this happen.
Yeah, but it sounds more like the way in the text the name of the vendors are used can be easily confused between a statement from a person from a company versus a statement about a particular hardware architecture. So I think it would be good to clarify that it is meant to.
Does it help, Torles, if I put the person name there?
I think I would say Juniper hardware and in parentheses from Kiriti, right? And I think.
Yeah, I mean, even we had, like, Kriti was mentioning that we had discussions with Broadcom, so
That's fine. That's fine. But I think that it would be good to be very explicit. What do we know about what type of hardware from whom?
Yeah. Okay, that's a good feedback.
Also here, I didn't say the architecture cannot do. I just say, first of all, there's no architecture has done that, and the second, if we do that, that doesn't help. So that I don't say it can do. Everything can do, of course.
That was what I was trying to make.
Let me start by from the designation. How are you? So what are you okay if I?
As this analysis, I prefer to not put Huawei's name there, but this analysis is based on, the current available chips on the market. Most of them commercial chips from Broadcom and Barefoot, right?
Did you did you get in touch with these commercial chip vendors, or
I
this
didn't
is
get just based on
your
the
investigation?
my previous experience and the available documents on the market.
Okay, so basically your own research reveals that.
Yes, yeah. Also, there's some input from guys with experience on chip design.
Yeah, and I think it would be fair to say that this was high-use analysis of the documentation of those, parser structures supported in those chips.
Yes.
So I mean, what comes to mind is, I just posted a draft about, also in the addressing that we're proposing for a next stage of beer, that we're also effectively having, an internal structure that's pointer based, right? So from that perspective, I think the question is always not only how do we optimize, but what functionality can we achieve, right? So I think we'd be careful to only make our decisions of where to go to based on evaluation what has been done so far. I think Hayu did well capture in describing of what has been done so far, primarily by the also the data center type chips like P4 and Broadcom. But I'd be very careful in making that a limiting factor for our design.
Exactly.
Okay. That's great feedback, actually. Do we need to capture anything else on this action item? All right. We had started last time, moving on to the next action item, we had started to look into some text that Loa had put together, and then we reviewed it, and we found that it has to be still revised again. Kiriti had volunteered to propose some new text. Right after we converge, we can take another, the next step, which is to send an email to the multiple working group and get consensus. I think the question.
I had proposed not exactly a design directive, but notes on backward compatibility. I saw an email from Loa saying, "Hey, this has got too much of FAI in it." I think he's referring to that, and I can revise that so that it's not, solution specific, but more general. And then, we can use that as a starting point for a design directive.
So in that mail, I also said that the only thing we need to say in the design directive is that you can't place more than one set of PSD after the boss. That's the only thing we need to say.
Actually, I think there's two things we need to say. One is you can't have more than one PSD after the bottom of stack. But the second is that existing behaviors remain as is. So if you're going to make new behaviors, have a new code point, have a way of distinguishing where the new behavior comes and where the old behavior continues. I think we need both because because a lot of the wording was, hey, the GACH shouldn't be changed. The control word for pseudowise should not have weird new behavior. And so the one way to do that is to say the MFN, which is what distinguishes these things. Existing MFN continues this behavior as is, no change. If you want new behavior, you have a new MFN, MPLS first nibble. So 0001 are sort of set in stone. The GACH is set in stone. And if you want a new behavior, pick a new code point.
I think that needs to go into specification. You can't make it a design directive.
I think it's a part of the directive that you don't mess with existing things. It's there in the directive today. I'm just telling you how.
I'm fine with saying you don't change existing things, and you can't have more than one PSD after the boss, and then it's period.
Well, MFN, using specifically the MFN, which is actually the answer, but I mean, it's not something that I invented. If you want, you can take that specific word away, or that phrase. But I think it's important to say you need a new code point. Then you'll ask, what is the code point? The way you make sure that current behavior is not affected is that you don't reuse an existing code point with new behavior. And I think saying that is okay. I mean, it's not subscribing to any particular solution, and it's not I mean, if you say don't mess with existing code points, what does it, or with existing behavior? People will say, what is existing behavior? For me, I work in specifics, so I'm sorry, I can't generalize too easily. The MPLS first neighbor of 0 is a pseudo-wire control word or a DepNet control word. Don't mess with that. The MPLS first neighbor of 1 is some OAM thing, I forget, but don't mess with that. And we've already defined 5 for beer. Again, don't mess with that. So if you want a new one, pick a new code point.
Well, can we maybe also think about the one high level point, which is yes, we want backward compatibility, but we can basically try to think that in the same network you can have backward compatibility, but when you let away, in specific label stacks, some of the complexity that these backward compatibility things do, then you can for new features achieve better performance or other better metrics. So that the solution is kind of split up in that way, insofar as that we may want to introduce new things that may not be compatible in the same label stack with old things.
So we're not talking about the label stack right now. We're talking specifically about post-stack data. And the directive that Lua had crafted had talked about GAL and ACH and control words and so on. And I was trying to sharpen up that text. And I agree with Laura that we have to walk that fine line between getting too prescriptive and too solution oriented. But at the same time, I don't want to say don't mess with current behavior, but we don't know how you understand current behavior. So there's a fine line to walk here, but it's nothing to do with the label stack right now.
No, but I think would the same thing not also be true with post label stack things? In terms
So we're talking right now about post label stack.
No, understood. But what I was saying, I think should in general also be true for post label stack, right? So just because we're saying, an implementation needs to support backward compatibility with existing functions doesn't mean that in the same packet you must be able to combine new post label stack functionality with any of the old ones.
I'm not sure I understand.
Turles, I think that they are mutually exclusive because it cannot be backward compatible if you have old style, for example, .NET ACH, and you have a new style.
So I think you're going even one step further in terms of we're not even considering in the same packets combinations of old pre-existing post-label stack.
No, within the same label stack.
No, wait, right now we're just talking, Kiriti wants us to talk only right now about the post-label stack.
It's not me.
But
there was a directive from LOA, which was specifically about post-label stack, that I was, it's not something that I'm doing.
You could have a pseudo wire carrying another pseudo wire, and if that made sense.
I think the wording that LOA has there in the directive does talk on a per label stack basis, and I'm actually okay with that. So I think we're in agreement.
Yeah, I say in a given label stack, meaning that it's only one label stack. And there could be more in the same pack.
Right, and each one could have its own behavior.
So the text that we had started to review last time, it's still where it is. Kiriti, are you saying that we're okay with the current version?
I'm saying that I will try to, I will see if I can sharpen it up without getting solution specific. And if I can, I will propose a text on the mailing list, and then we can weave it into the text that is in front of us now. And if everyone's happy with it, otherwise we'll leave it as is.
Okay. All right. So update is
I will send an email proposing a revision. Yeah. For PSD.
Okay, thank you.
All right. I'm probably going to drop off soon, but you
Okay,
guys
I
go
think I think we went over the next action item last time about the first nibble registry. Did we?
Sorry, can I ask a pointed question to one of the stack functions where I'm not sure that we talked about that, which was in the label stack, the the position on us carrying forward the need to parse looking forward into the label stack, like for the legacy things like ECMP or something like that, right? Which may be sitting a couple of labels down. So for example, I can't remember that functionality was covered as something easy to do in what Hayu was presenting, because it's not an explicit parse, but it's a scan. And so I was wondering if we made a statement about that, right? I'd love to see backward compatibility, but in new function label stacks, that not to be supported anymore.
Well, I'm not sure what the question is. I will tell you that ELI has been implemented. People do scan the label stacks. In fact, they do two things. They scan the label stack looking for an ELI. They also just scan the label stack and feed that all into their hashing engine, except special purpose labels, to improve the hash rather than using just the top label. And they, of course, do go beyond and see, hey, the MFN is 4, so maybe there's an IPv4 packet. But definitely scanning the label stack is something that happens today. So
right.
if you
I'm
talk
trying
about
to
backward
remember
compatibility,
if it was captured by Hayu, but from my best understanding, it's not something that would be easy to do, for example, in the lower end chips like Barefoot or so. Hayu, do you have opinions about that?
Your question? Can you repeat your question?
The scanning of the label stack for that ECMP thing, for example, where you need to.
Sorry, Torles, I have to go. So can I just give a very quick update on the MPLS first nibble, and then
Yes. Yeah.
and then I have to drop. So I have updated the draft. I did post it. I have a slot in the common PALS DetNet MPLS session for this. Apologies to folks that not all of the comments have been put in, but this is a draft, and I wanted to have a draft so that people can read it before we get into the meeting. I haven't made any dramatic changes from the last one, but I did try to sharpen up some of the text. So there is a slot in the PALS, the common MPLS thing. So I just want to give you that update, and I'm gonna drop. Sorry.
Okay. Thanks,
Yeah,
Kiriti.
you guys go ahead. Cheers.
Okay. Torles, you were interrupted.
Yeah, no worries. No, I was trying to remember, and I don't think that Hayu's rundown that we got to the point whether the scanning of the label stack was basically part of the standard machinery of the parsers that he was showing.
For those kind of chips, they all scan all the MPLS labels, and if it's a program to also checks upper layer protocols, it's also continue to scan all headers. That's always what the parser does, is to first get all the available headers cared by this program first. Then in the later stages to process those headers as needed.
So basically you showed state machineries, right? So
yes, that state machine can be very complex, but because it's very fast, the throughput of that parser is never a concern. It's still much faster than the following pipeline can or processor can support. So I will show a complex state machine for parser. It can parse up to 10 labels plus the many upper layer protocols. So that's no.
Yeah, but remember that I think so. I think we need to be quantitative here and not qualitative, right? You're saying it's very fast, but obviously the more instructions you're having, I think the more you're getting into the pipeline issue that's parsing state machinery, also works on a clock cycle. So if the parsing state machinery is, at 20 versus 50 steps long, then it basically will take longer, which is not a problem by itself because of running at the maximum speed, but you may need to be able to have, n instances of that on the chip to run in parallel so that you can keep the pipeline of the packets full. So I'd be very worried of making very generic assumptions about state machineries that could be arbitrarily large. I would rather think that if we want the state machinery of existing systems to be able to parse more of the extension headers we would like to do, that we would want to reduce the complexity of parsing the label stack up front. And that's where that scanning comes in as yet another part of the state machinery.
It's just needed one cycle to scan per header usually. If you just chain all the headers together, then also they have at least for the chips I know is they have a multiple parallel parsers working together to achieve a very high aggregated throughput. I have some figure and the numbers show in my presentation. You can look at that. It's
I think the thing is, without having an actual quantitative number in terms of when we don't know how large a state machinery can be before it impacts performance, it's very difficult to make conclusions from what you said.
So I think the problem is that there's a huge amount of variation in the industry today on how deep you can parse in the different implementations can parse today in the label stack, and presumably the impact of parsing on throughput. And we've all, it's well known that there's issues today with deployed networks where there's older implementations out there that can't parse very deeply in the label stack, and this causes problems for operators with entropy label today. So you just need to be really careful in the design to not make assumptions that everything's running the latest and greatest.
I have a concern with the parsing a little different. What if there are different indicators that point to different functions at the depth that can be parsed, reached, looked at by the given node? So how such situation can be managed and resolved? So would we say that, oh, you find the first one and you stop, or how the arbitration will be? So I think that the simplest way will say that no part, okay, you parse at your own risk. You do the lookup beyond the top of the label stack at your own risk.
Greg, there was a readable label depth capability. We talked about it earlier.
Yes, there is a readable, but again, since and that's only in regard to the entropy label. But since we are introducing multiple different functions, so their number of combinations is enormous. And I think that this idea of looking through the step beyond the top of the label stack, it's a very complex and if not risky proposition.
I'm not sure what your question is correct, but Yes, there are two concepts. The first is that's a readable header buffer size. That's a very critical. It's a variable for different chip, right? Then, but within that is up to the program to decide how deep you will read, you will process. So
Yes.
if you don't process, for example, if this node don't process any extension header, so the program itself will tell, okay, you stop at the location. You just finish here, then your chip can only process the header passed so far. So how within the window, how many layer of headers you want to process is up to the chip, the program design for the chip.
Again, I think that everything will be much simpler if we say that we do not rely on this ability to look up for number of labels down, and this can be only activated on the node if this is top of the label stack, because then it becomes very deterministic, very clear.
Okay. Is this discussion related to the requirements spec? I hope it will drive requirements.
Yes, I think it's directly related to requirements.
Yeah, so if we can hold off until, Matthew gets a chance to start talking about it, and he has to leave at the top of the hour, he didn't indicate that. I will move on and give you a chance to come back, Greg, with your concerns at item number 3. Is that okay?
Eric,
Yeah.
while we are at the discussion of what goes after the boss, I actually, to make things even worse, I put a new Rev 3 after Kireti's text, and it's very short. And I sent it out in the chat, and if people are interested, they can look at it.
Okay. Yeah. Okay. Item number 4, I guess. This is what you mean. The revised text for consensus call.
Yeah, but we had that discussion before.
Yeah, it was an action item, and I guess Kiriti, yeah. You're saying
Yeah.
that there is a Rev 3 in the same page?
In
That's
the same wiki page, yeah. You have it there. Yeah.
Yeah, this one. Okay, all right. Okay. Do you want to talk about it now, or should we give
I'm
you a
saying
chance?
what I'm saying. I said it like so many times. I just feel that I don't need to talk about them. Two things: the things that are there need to stay as they are, and when we do new solutions, we can't put more than one set of PSD after the boss. That's all we need to say. It doesn't matter what the first nibble are. What
Okay.
happened?
Yeah.
I think that what's in revision 3 on the page that you have on the screen now is what we need. We don't need anything more. The rest is probably specifications or out of scope.
Okay. Yeah. I have concerns with your text. I'm made that doubt, not concern. It's a doubt. If I have a pseudo wire steered on a network slice, do you have any concerns there?
It's a pseudo wire, it's specified in a specific way. It needs to stay as it is.
Yeah, but the pseudo wire is actually steered in the network over a specific network slice. Or maybe I want to enable, yeah, IOAM on the pseudo wire. Is there a
That's going on at the MPLS layer, isn't it? The pseudo wire is only is an over-the-top service between two endpoints. How it gets between those two endpoints is a matter for the LSP, not a matter for the pseudowire. If the pseudowire is constrained to a slice, that is a matter for the slicing architecture. The same with DetNet, by the way.
Yeah, but imagine there's a pseudowire and I want to enable IOEM on the packets that traverse the pseudowire.
Well, you want to run if you want to run IOEM on the packet that's carried in the pseudowire, that's outside the pseudowire scope.
Yeah, so you run on a transport, not a pseudowire.
So there will be a metadata header after the bottom of stack for the IOEM, and there might be a gap.
Well, in that case, what you had better do is to set up an LSP, terminate the pseudowire, so terminate the transport label stack, and then put the pseudowire underneath it as a separate stack.
Ah, okay, I see.
Because I think we've already agreed that you can't mix and match these different OAM mechanisms at the bottom of the stack. It just doesn't work because the pseudowire one has no way of knowing how the other one exists, and the pseudowire can't be an old-fashioned pseudowire. It would need to have other things sort of in it. Would need to be a new pseudowire type. So, if you want to do IOAM on the LSP, which I think is what you said, then do IOAM on the LSP, and then when the LSP has arrived, take that away and discover that you're carrying a pseudowire, which is terminated at that node, and then process that.
Okay, what I heard you say, Stuart, is two label stacks. So terminate the first label stack.
Yep.
And then, right?
Then dispose of all that information.
Right.
And what you discover is that the payload is a pseudowire. So actually what would happen is you discover the payload was of type MPLS. You'd look the pseudowire label up in the global label table, discover it's a pseudowire, and then process it.
I'm happy with that if we can clarify. I mean, that's fine by me. Is that clear from these two sentences? If it is clear for everyone, I would like to clarify.
Tarek, I think that this is a very interesting scenario, but we're trying to find, as I understand, a more general solution.
Well, we can find another solution, but I think the first statement is correct, right? An existing pseudowire or DetNet shall continue to work as it does today. That is to say, providing it's running over an LSP and not doing anything strange, all that sort of stuff, it just works. If you want to do something different to it, then you either build a new pseudowire or a new DetNet, or you transport it over. You build a transport network to carry it.
Okay, I think the second sentence embeds a lot of subliminal messages there. But I'm okay. If it is vague, then multiple solutions can fit in.
No, well, it's not clear what the scope is, but the thing is that it's very clear on what you can place after the boss.
Right. I think actually what you meant is new solutions may be designed such that they can carry more than one set of PSD after the bottom stack.
Actually, yeah, that is kind of the definition of set, isn't it?
Yeah.
You might, if you think in TLV, you might say that, okay, we have one after the boss TLV. That could include sub TLVs from, for example, hop by hop or end to end. But together they constitute one set. Okay, now I confused everything. Good.
Well, aren't we just saying that PSD can apply to multiple contexts in the sense that it can imply multiple behaviors or multiple functions being applied to the packet? So So just like you say, if you stack multiple subtail Vs in there, each one can point to a different kind of treatment that you
Yes,
have to give to
but
the packet.
that is not
But-
designed yet, and we can't decide on the design before we have looked at it.
Right, but well,
we-
okay, another
but
way
we-
to look at it is the indicator in the label stack that there is PSD. There's one indicator, and it's not pointing to multiple blocks below.
That's about true if you actually look at the 5 proposal, but if you actually look at Jan Drake's proposal, it's not true. So what I'm saying is that you can only have one set of PSD after the boss. That I think is true. Then the PSD can be very complicated and actually have more than one action. Fine, but it's still just one set.
Yeah, but you just need something that says this set exists. You don't have 2 pointers from the label stack saying, look at these different sets or this different parts of the set. You just, so it's one exception, if you like, to then go and process all of the different actions in the PSD or implied by the PSD.
So you say that no more than one set of PSD can be placed out after the boss. However, the PSD might actually carry data for more than one network function or forwarding action.
Yeah, why not? Yeah.
Okay, fine. I can add that.
Loak, is it fair to say that we can have more than one PSD in multiple after multiple bosses? I think that this statement is saying I'm okay with the statement saying that.
Every boss is a world of its own.
Okay, that's fine. That is exactly what I wanted to hear is we can have multiple worlds with multiple PSDs in the same packet.
So I'm not talking about packet, I'm talking about the boss. If you have 5 bosses in the stack, you can put PSD after each of them.
Yes.
But it's
Lower, you don't have 5 bosses in the stack. You have one bottom of stack for the stack.
Yeah, okay.
But you may have a stack, you may have an MPLS label stack carried in another packet, which is itself an MPLS path.
So you might have more than one boss in the packet,
but not in the label stack.
I understand. Yeah, okay, that's fine. I can tweak that a bit, and then I think we should treat Rev 3 as the main proposal and go forward with that.
Okay. Yeah, I mean, I wish Katie was here. It's very crisp and straightforward. Yeah. I'll wait for your update on that.
Okay, I will do that today or tomorrow.
Okay, great. I'll go back to the agenda. I do have an update. I owe the design team an update on this one, on the use case status report. So we do have a GitHub repository, and there is a drafts directory there. There's drafts. What I've done is I've added the requirements rev that was shared. I think I took it from the web that Matthew and Stuart had put together. It's already on our GitHub. So people can go ahead and review and add comments and as usual. And you can push updates, revisions to the GitHub account, to the GitHub repo. I also updated the use cases document. It's not pushed into the Ietf repository, but it's sitting on our GitHub. And I did not add all names because I didn't get a chance to, ask all the reviewers who signed up to review. It's a Rev 00, and there are sections that need to be expanded on. So I have a link for it, and I'm encouraged. I'll leave it on the wiki, and design team will have to go and review that, and eventually we'll push the 00 revision out for the use case, the MEAD use cases. So we do have both the requirements draft as well as the use cases draft are on our GitHub GitHub account for MPLS working group. One note is that if you want to push new drafts to this repo, you might need an account in GitHub. So do open an account, and if you need the permissions or run into issues, reach out to me and I'll have that you want. Any questions or on the use cases or even on the machinery to push or update these drafts. Logistics, I guess, no? Okay, good. All right, I think I'll give you less than 10 minutes, Matthew, to talk about the requirements. And I'm happy to open the page if you want for the...
Yeah, thank you. I can share it actually.
Yeah, that's fine by me as well.
You see that?
Yep.
Okay. Actually, I'll scroll to the top. So this is the first draft of the requirements draft. So just to thank you to, we posted it a couple of weeks ago, but thanks to those who have commented so far on the list, and also thank you for rearranging the meeting from last week because I couldn't make it. So just it's a very first draft of this, obviously. So we would appreciate any further input. But just to be clear, that the idea of this is requirements on the protocol development work. So it defines what the protocols should be, or extensions that we do should be constrained by and achieving. It's not a requirement on implementations. We also started to, so the first significant thing is that we started to really nail down some of the terminology, particularly what we mean by ancillary data and the term ancillary data indicator, as we felt that we needed a formal definition of those. Then there is a little bit of background, which is mostly borrowed from some of the existing solutions drafts and from Stuart's MPLS design draft. And then the draft lists some high-level requirements for the design of MPLS indicators for ancillary data. So section 2.1 is really the meat of the draft, and this lists a number of high-level requirements. And I guess there's a sort of a theme running through these requirements around trying to make use of the existing MPLS functionality and the existing MPLS architecture. And there's one of the other principles in this was to try and avoid going down the route of allocating many special purpose labels for these different ADI type solutions or ancillary data solutions. So now we're very limited in the number of special purpose labels that we have available. So really I think this is really pointing us towards coming up with a new exception mechanism. Obviously, this needs to coexist with and not obsolete existing MPLS mechanisms. I think another principle is we need a mechanism there to ensure that ADIs or ancillary data are not delivered to nodes that are not capable of processing them. So if you don't, in MPLS today, there's no equivalent of the kind of U bit in LDP where you can just kind of ignore something if you don't understand it. And if you get, for example, a special purpose label state, you toss the packet away if you don't understand it. So that is actually that could cause issues with legacy networks. So it's really incumbent on the head end to not insert this into an NSP that it doesn't think that that any node processing that label will not understand it.
In particular, it's important that the tail end who's got to get rid of it knew it was going to be there and can get rid of it.
Right. Well, there's two things. There's the tail end. If the tail end needs to know how to handle it. If we do end up going down the route of scanning the label stack, you shouldn't scan the label stack and then hit one of these hit one of these labels and then go, oh, what's that? I don't understand it, therefore I'll discard it. It needs some kind of some consideration of what the processing should be in that case.
Hey, Matthew, a question, please. We were talking earlier about a requirement not to have more than one PSD in one label stack. Is that captured as?
What I did possibly not.
I haven't read in full the draft, so I apologize if it is.
I know I meant to. No, it's actually incorrectly. I think it's incorrectly in here. It says it should be possible to include indicators for ancillary data for multiple applications in the same packet, but each ADI only supports one application. And actually, probably the latter part of that, the second part of that sentence is incorrect based on what we just talked about.
Should be possible.
Incorrect how?
That implies multiple ADIs.
Multiple ADIs in different label stacks should be possible, right?
Yes,
Yeah,
it's
it's packet,
isolated.
isn't it? Yeah. I think we need to clarify this in this document.
Well, hang on a second. Isn't this talking about the Cariti thing where we have multiple ADIs in his FDI?
FIA.
Whatever it is, yes. Forwarding action indicator, FAI, yeah.
Yeah.
It should be possible to include indicators.
For the same ancillary data, multiple. Okay, is the sentence trying to say that I can do multiple ADIs to the same ancillary data?
No, it's if you've got. So we need to discuss how you handle it if you have multiple ancillary data. For example, lowers.
So let me try and see if I understand correctly. Let's say you have a file style. No, that's not good because then you only have an H bit. If you have a file style with an H bit saying that there are PSD, and then you have a structure in the PSD that actually relates to more than one forwarding action. Isn't that okay?
That's okay.
Yeah, isn't
the
that what this?
No, but it's the ADI, the ancillary data indicator, is the issue. It's not. So let's say this takes the. Let's say that you've negotiated a particular label to mean I have ancillary data number 1, and you can negotiate another label to indicate that you have ancillary data number 2. You wouldn't. I think the question here is: do you stick both label for 1 and label for 2 in there, or do you just have a label, an ADI label that you've negotiated the value of that says just be on the stack, and then you find this TLV structure that can have as much ADI as you know, as much ancillary data as you like in it. It's like just the way the pointers work from the stack. So when you're parsing the stack, you might sort of bust out at the first one, but and go look, immediately jump to the bottom of the stack, or do you need to walk down all the way through, collecting all your ADIs together, and then find multiple ancillary data containers or TLVs or something at the bottom of the stack, below the bottom of the stack? I would have thought you only need 1 in the label stack, and that can just say there is some ancillary data.
I'm starting to see the problem, but I think the text is there. It's kind of almost correct.
Yeah.
Yeah.
Yeah, it's almost correct, but I think, as I say, the first bit is okay. It's the second bit that is probably not right, because to me that says for each of those, say let's say, it's just as an example, we have multiple sub TLVs in the ancillary data. This is like having an ADI pointing to each of those sub TLVs, because the sub TLVs are different applications. Whereas really, I think we just want 1 that says there's some ancillary data.
Okay. I think it needs to. We need to think about that a bit.
Yeah.
Uh,
I mean,
so if you think about the way that John set it up, with one flag field for end-to-end and 1 flag field for hop by hop, I think you can have more than 1 flag in that flag field for end-to-end set.
Clarification, or maybe a correction, Loa. John proposed different ADIs. So an ADI for hop a hop and another ADI for end-to-end.
That is correct.
Okay. But does it mean that if you look at the end-to-end flag field, can you only have 1 flag at a time set?
You
No, I
can
don't
have
think so.
multiple. Yeah, you can have
Yes.
multiple.
Yeah.
So they go in the same PSD set, as I would say it.
The applications, they means who?
Now, you have data for the applications, right?
Mm.
And now you have 2 flags set. So you need 2 sets of data. And they go in a PSD set together.
Okay.
Is it up? Oh, we should have a whiteboard.
Yeah, there was quite an interesting package I used recently called Miro, I think it was, that was really good for doing that sort of thing.
Okay, can you?
You want to draw something? Is that what you're saying? You're asking, Loa?
I think
There is a
I need a figure to put the question correctly. But the one problem now is that we have the 2 different proposals about how things are indicated. So we need to be writing something that is independent of which one of those way of indicating things you're using.
Yeah, I think you can annotate. You can request. I think I did request now. Matthew is sharing. Oh, he gave me permission. So you can actually draw. What do you want to draw? Were you able to see what I drew on Matthew's?
Yeah, I saw it.
Okay, go ahead and request that. On the left-hand side, there should be a annotation request. I can
Where does on the left-hand side it says file, edit.
ask
No.
control. Do you see any ask control?
No.
No.
There's something weird going on because it's asked. Okay.
Yeah, I did
It's
ask.
it does it on my whole. It's showing my whole desktop, which is not right. There's something weird going on. Just a minute. It was supposed to share.
We still see what you're sharing.
Yeah. Can you see my whole desktop or just?
No, just the notepad.
Yeah. But when you annotate, it annotates in arbitrary places on my desktop.
Ah, okay.
So, and it's now highlighted my whole desktop, which is really odd. Right.
Okay.
Let me just stop. Let me just pause the sharing. Let me just unshare and reshare.
Maybe it's a bad idea to annotate then.
Let me just do this because it's done something weird. Yeah, it's broken something when it did it. Yeah. Let's show my whole point. Okay.
So where do I? Ask annotate. That's what you
Yeah,
want me to do.
that's it.
Okay.
Right.
I press request.
Then I approve.
And then I can draw like that. Okay.
Yeah,
And
but
that's a flag field. And then you have the boss a bit lower. And then you have data here. So if you have two flags set here, that's possible, isn't it?
Yes.
okay.
And
I
then you
can't
need to,
lower as editor. I can't see what you're annotating. Weirdly,
well,
it's your
can I
annotation
Ah.
appears off my. Yeah, it's not on.
Oh, that's because you're sharing the document on the left, and he's using a lot more space.
Yeah. It's not actually over the top of my
Hmm.
document. It's just on my back. It's just on my desktop. What his annotation is appearing.
can anyone else see?
Yeah, I can see what you're doing.
Yes, I can see.
So what I'm asking is that in this field down here, I can have two different can I write? No. So I can split this field in two and have one of the flags up here pointing to,
Yes, that's what John Drake wanted to do.
and then the other one
Well,
is here.
I think indicating rather than pointing. I mean, some of us have suggested pointing. He was just saying that simply that there would be an indication. And what his proposal was that you'd have you have a bit field of bits. Is John on the call? No, right. You'd have a bit field of bits. If a bit was present, then the data would be present. If the next bit was 0, then that data would be absent. If the third bit was set, then that would immediately follow the first block of data.
So you have a 0 here.
Yeah. So yeah.
Okay.
Consequence
So
of
now-
this is that when you've run out of bits, you have to allocate more bits, and you have to carry the zeros with you in the in a longer indicator block.
Okay, but you have one indicator block for end-to-end and one indicator block for hop by hop.
I believe so. I believe that was his plan.
Yeah, that's. I think that's what John said. But now I have the problem back again. What is wrong with the requirement over here? Maybe ADI, but I still feel it's right. I still feel it's what you want to say is correct.
Yeah, I think at a high level, you're right. I think after your description now, where you've got that, if you take that bit as being the ADI, then
Okay,
so you've got an ADI block in a label stack. You've got an ADI block in a label stack, and then you have different bits in that indicate different applications. That's fine.
So when we have to decide if the IDA is, I thought that the IDA was a grouping of either FAIs or NFIs. Is that correct?
So the next bullet, the second part of the sentence, it's saying that, but each ADI only supports one application. You might have said that we need to correct this, right?
That's okay. No, I think you need to support more than one from the same flag field.
Yeah, one ADI can support more than one application. That's what we're talking about.
Okay.
So yeah, that's fine.
So Matthew, did you capture this and can kind of correct the text?
Yeah, just let me turn that off a minute. So it's really the ADI block. The ADI block can support multiple applications, but the flag within the ADI block. So you have a one.
Did you define the ADI somewhere in that text?
No.
Okay.
So okay, so anyway, this is kind of I can wordsmith this offline, but is this in principle what we're saying?
Thing. An IDA block is
One,
Yeah.
not n, one.
it's a set of indicator flags, isn't it?
Hang on a second. ADI is the indicator itself, not the indicator block.
Yes.
Yes.
So it's correct to say each ADI only supports one application.
Yes.
So I think we got that correct, actually.
Each
Okay.
ADI.
This comes down to our definition of an ADI again.
Exactly.
And that's the problem.
Yeah.
That's what. Sorry.
Oh,
That's what
ADI
we were
is
trying
not
to
a
do with our
special
definitions above.
Okay. ADI is not a special purpose label then.
No, it's not necessarily a special purpose label, but it might be a label. It might be an LSE type thing that you've negotiated that you stick in a label stack that's got various bit fields in it.
I think we are we took the high ground here. It's however we decide to do ADIs, those ADIs will have the characteristic that an indicator indicates one piece of functionality. I think that's what we were trying to say.
Yes.
Yeah, so I
Stuart,
think we should be careful here, as this ADI is exactly what I mean, the catalog. At one point we also agree that all the labels follows, all the functions should be self-explanatory,
Who
which
said
means
that?
by simply look at those labels or auxiliary data, we know what their function is.
Hang on, where did we get to? They have to be self-explanatory.
Yeah, it's in the email exchange, right?
No, I am not convinced they need to be self-explanatory. There's nothing else in MPLS that does that. MPLS is keyed off an opaque type being bound to a particular piece of functionality by the control plane. I think we should tread very carefully if we throw that away.
Yeah, I mean, for some special labels, the special label has.
Well, there's only one in the whole of MPLS. There's only one special label, I think, that really does that, isn't there? And that's Cariti's label. And remember, if you go back to the beginning of this text, special labels really are the technique of absolute last resort.
No,
That's why we've still got so many left. I mean, not that we've got many left, but the reason that we've still got any left at all is because we only use them if this is the only way to do something.
So, so by far we have defined several special labels, and we know what they mean, right? Yeah. So I have other opinions, and that we should not continue to use special labels unless it's absolutely necessary, because if we have ways to add a post stack data, those that we should do that. That's a
right. Now the question, the fundamental question is: are we designing IPv6 or are we designing MPLS? Because they have two radically different design philosophies. Are we only swap from one to the other?
I'm a bit concerned. We are discussing requirements that actually expresses what we want to do, and then we kind of fall through a trapdoor down into the basement and start discussing bits and bytes and maybe SPLs and other. We need to define what we want to do. That's the requirements.
Yes.
And if you want to implement it in one way, that's okay. If someone else wants to implement it another way, it's okay, as long as they are compatible.
So yes, I agree. But this ADI mechanism seems to suggest some particular implementation, right? So
no, I don't think we were suggesting it. When we wrote this, we weren't suggesting an implementation. We're assuming that there is this thing somewhere in the stack that is the ADI. We're not saying how it's done. We're just saying that it is there, and we're saying that the ADI points to only one thing in the or indicates only one thing. Actually, it could be anywhere in the packet. So you have a bit, for example, that create one of Creti's special examples that says no fast reroute. Well, that's exactly what it says. That's what it always says.
And no data at all.
Well, in that case, there is no data in that one, no. And I think we do cover the various types of implicit and explicit data in the earlier part of the document.
All I say is that if there are some special purpose labels in the stack, we might not need the indicator at all. And if we have post stack data, that's why we might need this indicator, because that will tell the parser to pass beyond the label stack. So that
maybe
I think that's all we should know. And anything beyond that, that's some particular implementation suggestion.
I think we should finish going through the requirements, because the requirements do not specify how anything is built. At least they're not supposed to.
Yeah. I mean, I think all this is saying is whatever this ADI thing is, there's a one-to-one mapping from ADI to application, but you can have multiple of these indicators. You can have multiple applications supported. And it probably should say the same label stack here, not packet. This packet seems to just put these around for edits that I know. Okay, it must be. Okay, so then there was a statement: it must be possible to insert new ADIs for new applications on the same LSP. So this is basically, you've got an LSP that's up. You've got an ADI inserted on it for a particular application, and then you want to add another one. That's all that means. Okay, it must allow ADI and non-ADI packets to coexist on the same LSP. If you have multiple ADIs on the that should be label stack again. Not forced to process all of them. It must be generic to whether or not it needs to be processed in the slow path or fast path. Must support hop by hop processing or end-to-end processing. Okay, you've got to be able to support, I think we've already covered this, hop by hop and end-to-end simultaneously. So this one here, in order to prevent unnecessary scanning of the packet, care needs to be taken in the location of ancillary data. For example, it should be located as close to the label stack as possible. So the ancillary data that goes below the bottom of stack should be very close to the bottom of stack, not buried off in some endless layer, in some layer 5 or layer 6 encapsulation. Okay, and then we had on the list, we had a bit of discussion around these last two about authenticity and confidentiality. I mostly put those on based on experience I've had with dealing with overlay and underlay networks and security in other working groups like NVO3. In other words, what you expose to the underlay MPLS network here really shouldn't. I mean, the security area is probably going to come back on us at this anyway. If we start putting stuff in the ADIs that exposes something confidential in the payload, we're going to run into trouble, I think, with that. So also, you must be able to obviously trust the ADI, the ancillary data, in terms of verifying the authenticity of it. Okay. Okay, and then we have.
I have a question. So you'll be presenting an update in Ietf 112, right?
Yeah, I think we should have a slot in the MPLS meeting to go
Yeah.
through
Okay.
this, for
And
sure. Yeah. I know we've got the. So how's this working? Because there's the MPLS meeting and then the Open DT meeting kind of back to back, but the
yeah, that's right. There's
So,
the MPLS and
but what's the difference? Because the Open DT is kind of the MPLS.
Matthew, the working group chairs will have a meeting beginning of next week, trying to organize the agendas. And it's still an open issue, open question where a specific presentation will go. I have added a request for a presentation of the requirement draft, so you're already on that.
okay.
Just now, we can't tell you if it goes into MPLS or into the joint meeting.
So,
Yep.
If it's in the main MPLS meeting, isn't it kind of presenting it as almost like the consensus of the Open DT?
That's what I was going to ask. Is it, are you presenting the consensus yet, or?
Well, no, because it's not. I don't think this is consensus. So it's just
agree.
a proposal.
Yeah,
So,
I think you have to be careful there, right?
It might be presented even if we don't have a consensus. It might be presented for discussion, but the less consensus we have, the more likely it is that it goes into the joint meeting.
Are we meeting next week on Thursday?
I think so, but I need to think about it.
Okay. And yeah, would you think that you'll have the slides for the requirements slot ready by then?
yeah, I can do. They're going to be quite simple.
Okay. I think, and
really,
yeah,
it's
at
just-
least
yeah.
Tarek, so if we're meeting next week, could you please an announcement make clear how the timing works for North America, non-North America?
Okay. We haven't changed this
But Europe has changed. Actually.
Europe
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 will
changed
change.
on Sunday. Yeah.
Europe will change.
Okay, yeah, that's fair enough.
But if you look at the mail I sent out to the working group chairs, it's in there. We can send the same.
Okay, thank you.
Thanks. Okay, I guess we can review then next week and get more consensus on the requirements so that it's, you know.
Yeah, it's probably just a case of making sure that the slides reflect the open discussion points. The more at this stage, otherwise, because so getting a bit more feedback, a broader feedback, as broad feedback as possible on some of the requirements that we don't yet have consensus on here.
Okay.
I think we're at the end of our meeting time, and I'll go ahead and stop the recording unless someone objects. Okay.